today we're going to use the rational root theorem. And what we're going to be ultimately doing is we're going to be solving a polynomial function. So we want to find the answers, which are the x-intercepts, the roots, or the zeros of the function. The thing is, guess and check, while it might be a favorite method of yours, is not really a favorite of mine because it takes a lot of time to use the guess and check method. And who really wants to use guess and check? But we can minimize how much time it takes by using the rational root theorem, which is here on your paper. And this is the actual math definition of a rational root theorem. I don't want to get too far into this, really dissecting the definition, but the p of x here stands for the polynomial in terms of x, and this actually is written so that it represents descending form and or standard form of the polynomial with integer coefficients. That means that we don't want fractions for our coefficients. And if we have a polynomial written in this format, we can limit the number of roots by using p divided by q. And the q is going to be the leading coefficient. And the p, sorry, I think I said that wrong. P is going to be the constant, and q is going to be the leading coefficient. I'm not sure if I said that right or not, but I said it right the second time. P is the constant, and q is the leading coefficient. So in other words, if we look at our first example here, the only one that we're going to get done today, when we start this, our P is coming from the 5, and our Q is coming from the 2. And I formerly had a student whose memory technique is this. She said, "Oh, I can remember this quarter pounder." And I said, "Yeah, I don't think that's going to work for me, but that's how I remember it now." Q first, P second. The Q is the leading coefficient, the P is the constant. So what is P? It's 5. And what are the factors of 5? Well, 5 is 1 times 5. Q is the leading coefficient. In this case, it's 2. It says list the factors of Q. Well, again, we're lucky. 1 times 2 are the only factors of 2. But what we're looking for is we want to find answers to this problem, but we can come up with some possible roots first that will be comprised of P divided by Q. So all teachers kind of have a different pattern, but I like to say 1 divided by 1, 5 divided by 1, and then we say 1 divided by 2, and 5 divided by 2, which are possible rational roots to our polynomial, 2x cubed minus x squared plus 2x plus 5. The thing is, when we list these, it doesn't just mean that it's positive values. These could be positive or negative. So as we look below here, it says, how do you know which possible root is actually a root? And we've got a table. What we're going to do is we're going to take our calculator and we're going to type in some of these values. And in fact, we're going to type them all in. The values being the first root that we had listed was 1, and our next root is negative 1. Then we have 5 and negative 5. We have 1/2 and negative 1/2. And finally, we have 5 halves and negative 5 halves. Those values just came from the list that you can see straight on your paper here, but I put on a separate page up here on the screen. But we just listed all 8 of these factors. So the first question is how did we get 8 from the 1? Well, what we did is we took our calculator and we typed in 2 times 1 cubed, not 11, but 1. 2 times 1 cubed minus 1 squared plus 2 times 1, and then finally plus 5, and we get 8. So we came up with that value 8, and we said that no, that's not a root, and we might have to talk about why that is or isn't a root here in a couple minutes. And you can see the table on yours. Our next root was -1. So what we can do is we can type in 2 times -1 cubed minus -1 squared plus 2 times -1 plus 5, and we get 0. So we're going to go back and we're going to fill that in. Do we think that -1 is a root of this polynomial? Well, let's keep exploring here. Let's try the 5 here. So we can do 2 times 5 cubed minus 5 squared plus 2 times 5 plus 5, and we get 240. And I don't know about you, I'm lucky here that I haven't had more trouble with the calculator than I have. But I wonder if there's a shorter way that we could do this so we didn't type it in all the time. And there actually is something that I like to use on the calculator. It's called the store button. And the store button, to the left of your calculator, you've got on, and then it's the button right above. It says STO with an arrow on it. And the next root that we're looking at is we're looking at -5. And if we use the store button, we're going to press store. And then I'm going to type X and enter. So if you type that with me, what's going to happen is every time that you type X in your calculator, it's going to recognize X as -5. But then if we go and we type our polynomial, 2x cubed minus x squared plus 2x, and then plus 5, once again, it's putting the value of -5 in for x, and it gives us -280. So we're going to fill that in our charts. But now we've got 1/2. We need to test all these roots, and again, it takes time, and this is what we had to do in the olden days, so to speak. But we can say 1/2 store x, and when we enter here, we get 0.5, which is the same thing. So now, every time we type in x, it's going to recognize x as 0.5. But we can also go back in our calculator, and we can highlight that function that we're working with, press enter, and so now we've got this function after the 0.5, and when we press enter in there, we're going to get a value of 6. And let's keep doing that with our remaining 3 here. So if we do -1/2 store x, so now every time the calculator has an x in it, it's going to recognize it as -0.5. We can go back up and highlight our polynomial that we're working with here. And when we press enter, now it's putting in -0.5 for all these x's. And we get 3.5. So if we try 5/2, so 5 divided by 2, store x, enter, go back and highlight the polynomial, and then when we type enter, we get 35. And finally, with the negative 5/2, and you're probably ahead of me even, negative 5 divided by 2, store x. Now our calculator is going to read x as negative 2.5 every single time. Go back and highlight the polynomial, enter, and then enter one more time. We'll get negative 37.5. So the question now is, to finish today, is which one or ones of these are roots? Anybody have any idea which ones? So Ashley says -1. Why? What's another name for root? It's 0. What did we get when we put this in? We get 0. All of the rest of them, we did not get 0. So one of our 3 roots, because it's a cubic polynomial, is going to be -1. This will be continued tomorrow, so it'll have to be a different video tomorrow, but here's video part 1.